Hello everyone and welcome back to Sets Reference. In this video we'll be tackling another LeetCode problem 2270, number of ways to split an array. In this problem we're given an array of integers and we're asked to find the number of valid splits at a certain index. And for example, a split at index I is valid according to the problem if the sum of all the elements before this index, including the element at this index, is greater than or equal to the sum of the rest of the elements in the array. Okay, let's see one of this example. So we're given this array and the output is 2. There's two good split, one at index 0 and the other one at index 1. So let's see why. So at index 0 the sum is 10 and 10 is greater than or equal to the rest of the sum of the elements from 0 to the end of the element. So we have 4, -8, and 7. The sum is 3. So 10 is greater than or equal to 3. So that's a good split. And the other one is at index 1. So if we consider over here, so we have 10 plus 4, 14, and 14 is greater than or equal to, so -8 plus 7, which is -1. So 14 is greater than -1. So this is a good split. And let's consider the index 2, the last index. We're not going to consider the index 3. So the index 2 is not a good split because the sum of elements, so 10 plus 4 plus -8, so we have 6. So it's not greater than or equal to 7. So the sum of the rest of the elements. So we have 7. So that's not a good split. So the answer for this one is 2. Okay, now let's actually draw this example again. We have 4 numbers. Let me draw it. So I have 10 over here. We've got 4, -8, and 7. And we have 0, 1, 2. Okay, here are the indices. Now, what we actually have to do in this problem is really obvious because it says find number of good splits or valid splits, sorry. And it tells you what a valid split is. So basically you're going to check the indices from 0 to a-1. In this case we're going to check from 0 to 1, 0, 1, 2, and not 3. And we're going to check to see if they are good split or valid split. Somehow I just keep saying good split. So for example, we can check if 0 is valid split. So how do we do that? So we need the sum of elements up to this index, and we also consider the element at index itself. For example, the sum in this case will be 10, right? And the sum of the remaining elements here. So the sum of remaining elements will be 3, right? And now 10 is greater than 3, so this is a good split. Now what we do is to move to the next index and do the same thing. So we go over here, and now again we need the sum, right? The sum and the remaining sum, right? So we have 10 plus 4, 14, and 14 is greater than or equal to the sum over here. So -8 plus 7, so -1. So 14 is greater than or equal to -1, so that's a valid split. Now we move to the next index. Now for 2, we have some 6 and over here 7. Now 6 is not greater than or equal to 7, so that's not a valid split. So in this problem, the answer is 2. Now what we can do, for example, when we check if a index, for example, a particular index like 2, if it is a valid split, we need to find the sum of elements before this index and after this index. Now, there's a way, for example, we can brute force this approach. Each time we can check, so sum the elements from index 0 to up to the index I, and the elements from index I plus 1 to the end of the array, right? But we can actually make this faster. For example, let's say we need, let's actually check if 1 is a valid split. For this, we have to find the sum of 10 and 4, like 14, right? And the remaining element. So there's -1. Now the next time when we need to find the sum, when we need to check if 2 is valid split, we will need to find the sum of elements from 0 to 2, right? Now for over here. Now how can we do this? We can go to the beginning, the index at index 0, and from 0 to 2 we can sum the element, but this will be slow, right? But if you notice, we've already calculated 14, so we can actually add -8 plus 14, so that we already know the number of elements, the sum of the elements prior to this index. So we actually add one number, so that will be 14 plus -8 will be 6, right? So we actually keep a running sum, and the remaining can be calculated as like that. For example, let's say we know the sum of all the elements of the array. In this case, it's 13, and we can calculate this. Let's say we know the 6, and the sum of this element will be 13 minus 6, right? Because we kind of like subtract this current running sum, which is the 6, right, from the overall sum. So the sum of 10 and 10, 4, and -8. We subtract this sum from the overall sum, which will be 7 for this one. How are we going to quickly calculate this sum for a particular prefix? Let's say this and the sum from this index to the end of the array. We can use the prefix array, the prefix sum array, or whatever you call it. Let me actually try. It will be one larger than the size of this array will be one larger than the original array. So we're going to index it 0, 1, 2, 3, and 4. Now conventionally we assign 0 to the element at index 0, and now the element at index 1 will be the sum of elements up to at index I minus 1 in our original array. So in this case, so for 1, the element, so the sum, it shows the sum of elements up to index 0, which is 10, right? So it will, so how we can calculate this? It will be the prefix sum, so the sum, previous sum, which is 0, plus 10 will be 10, right? Now for 2, let's say the sum over here, the sum up to index 1 will reside in our prefix sum at index 2. So how we can do that? We need to know the prefix, the previous prefix sum, which is 10, plus the current number, which is 4. So it will be 14. So that way we just fill in this array. For example, 14, the previous sum, plus -8 will be 6, and 6 plus 7, 13. For example, this element at 13, at index 3, 13, it is the sum of all elements of our original array. So it is the sum of the elements up to index 3 in our original array, which resides in our prefix array at index 4, right? So if we want to check, let me actually clear this. Now, if we want to check if an index is a valid split, what we do, for example, if we want to check if index 2 is a valid split, we need the sum up to this index and the sum of the elements after this index, right? So how we can do that? So we need the sum up to this index, up to index 2. It will be the sum. It will be the number at index 3 in our prefix array, which is 6, right? And the sum of the elements after this index. So it can be calculated like this. We're just gonna subtract the current running sum, which is 6, from the sum of all elements, which resides at index 4 in our prefix array. So 13 minus 6 will be 7. That way we find the sum of elements from the current index to the end of the array. Now, this is how we speed up the process of calculating the running sums of the sum of the prefixes and suffixes of the array. So the sum of like here and here. Okay, now let's code the solution. We need to know the number of elements, nums.length, right? And we need the prefix array, prefix sum. Let's go new long. It will be 1 larger than the original array. And let's actually fill in the prefix array. Prefix sum I will be prefix sum I minus 1 plus nums I minus 1. Okay, I've used long to avoid the overflow. Let's not count the valid split. We're gonna start from 1 to up to n. So I use 1 because our prefix sum starts from 1, so indexing starts from 1. So the answer will be okay. Now prefix if the current sum, which is I, greater than or equal to the prefix sum n minus prefix sum I, then answer would be, so we're just going to increment the answer, and at the end we're going to return the answer. So this part is basically where we check the good split. So we have prefix sum I, for example, for index 2, we check if it's a valid split. We need to know the sum of the previous element, so 10 for -8. So it's at index I in our prefix array. So prefix I, that's why. So if it's greater than or equal to prefix n, it's basically the sum of all the elements of the array minus the current running sum. So it will be 13 minus 6 is 7. So that way we check if it's a valid split. Now let's actually run this and see if it works. Okay, now let's submit. Now let's see. Okay, it passes, and yeah, it works. Now what we did, now let's review. We just calculate the prefix sum of the array. Now we have this sum 1 larger than the original array. Now in fact, if you notice, we need a current running sum. For example, if we're at index 0, now it's 10. At index 1, it will be 10 plus 4, 14. If you're at index 2, it will be 14. So we already keep that in mind. So 14 plus -8 will be 6. And how we can find the remaining, we actually need, if we know the sum of all the elements, we can subtract the current running sum from the sum of all the elements. That way we're gonna have the sum of all elements, so the remaining element, from index I to the end of the array. So we don't actually need this auxiliary space here. So we can completely ignore and just this prefix array and just have one running sum and a variable, for example, like the sum of, let's say sum, we can call it sum. It will be the sum of all elements, and that way we can calculate so we can find the number of good splits. Although for this problem we didn't need to explicitly calculate this prefix sum array, we only needed to have a running sum, and we need to know the sum of all elements. But this prefix sum array comes handy in other cases. Let's say you want to find the sum from, this is a little bit messy. I'll just clue here. Let's say you want to find the sum from index 1 to 2, right? It will be -4. 4 plus -8, it will be -4. Now, how we can do this? We can use our prefix array. For example, from this will be the sum from 2 to 3. So we can easily find this like that. We can subtract from the rightmost element in this range, which is 6, right? The element before the leftmost end, which is the 14. The element before that was 10. So 6 minus 10 will be -4. So prefix array is actually very useful, especially in cases where you want to speed up these sum problems, the subarray sum problems, where you're given some queries from, let's say you're asked to find the sum. So let's say you're giving queries, so it has a left and a right end. Well, let's say you need to find the sum of elements between 0 and 5 or 2 and 7 of a certain array. So in this case, you can calculate this prefix sums and easily find the sum of elements for each query. I hope this video comes handy and it will help you. So I'm planning to make some specific videos like on grid algorithms, dynamic programming, or some kind of binary search patterns, or let's say prefix sums. I'm going to actually consider making a separate playlist for each of these patterns or techniques like data structures or algorithms. I hope you'll find them helpful as well. And if you have any special problem you want me to consider, write them down in the comments and I'll be happy to help. So see you in the next videos. Happy coding.